So I just recorded the session. Namaste everyone. So this is our seventh, series or seventh episode of mathematics focused webinar series. So I've been conducting. So we have already conducted six series on different topics and areas of particularly related to mathematics. So in today's presentation or in this episode, we have two great and beautiful presentation related to mathematics and mathematics education. Similarly, how to teach mathematics in a meaningful way. First presentation will be done by our Harsha Bahadur Chandra sir. So he will be presenting his ideas on representation of mathematical concept and esteem education. So he's actually blending these two ideas: mathematics, mathematical concept, and the perspective and the method or the some theoretical things related to theoretical and practical things related to STEM education. So he will actually try to blend these two things. So Harsapathu Chand, sir, are you ready with the presentation? Sir?
Okay, sir. I am sharing my screen.
Yeah, sure, sure.
Is it visible, sir?
I think it's coming.
Hello.
That's visible, sir. That's how it's
May I
visible.
start now?
You can go ahead. Yeah, sure, sure.
Okay. Namaste and good evening to all. It's me, Harsha Bahal Chan, scholar of MPhil in STEAM Education at Kathmandu University School of Education. And my topic of presentation is constructing representations of mathematical concepts through STEAM education. Overview of presentation is I will be talking about representations in mathematics, understanding mathematical concepts, short introduction of STEAM education, and representations through STEAM education. I will share my experience, and finally I will conclude my presentation. Regarding representations in mathematics, constructing representations is basis for determining understanding. It means without constructing any representations of mathematical concepts, it is almost impossible to develop the understanding of any mathematical concepts. By Howard and Carpenter, there are two types of representations. First one is internal, and internal representation is related to mental imagery or schema. Schema means simply different type of informations that exist in our mind and the connection between such types of informations. That network is called schema. And it is also mental imagery. It means whatever evokes in the mind of the learner for any type of mathematical concept is his or her schema. And we cannot observe from outside what is the internal representation of students or internal representation of any of the person. And regarding external representation, external representations may be spoken language, any fixtures, graphs, symbols, drawings, or any physical object. And we may ask a student to express the external representations by asking definitions, to ask them draw fixtures, draw graphs, or any drawings, etc. And we can observe external representations from outside as well. Regarding their connection between the representations, there are two types of models. First one is the vertical model. Vertical model represents that, for example, if we are dealing with the square, quadrilateral, rectangle, etc., there is a big picture. That is, the larger set is a set of polygons. Uh, Within that set, there is a set of quadrilaterals, then set of parallelograms, set of rectangles, and set of squares. In this way, these concepts are connected in a vertical way. One concept is subsumed under the another concept. This is one of the connection between the representation of different concepts. And another, right? Another concept is webbed model. In webbed model, different related concepts of mathematics are related. Hence, this is the second type of model, webbed model. Mainandi also mentioned different type of models of representations. Graphic representation, which includes figures, diagrams, pictures, drawings, etc. And algebraic representations, that is when we express definitions using symbols. For example, epsilon delta of definition of limit is algebraic representation. Symbols, formula, these are algebraic representations. And verbal representations, that is language. Another is, for example, the concept of limit of function is one of the concepts in mathematics. And if whatever evokes in the mind of learner by dealing with limit of function is his or her mental schema, and if a student say definition or draw some graphs, draw some picture, or some use some physical models to represent limit of function, that is external representation. And in this way, in mathematics, internal representation and external representations are very fundamental for the understanding of mathematical concepts. And now, based on the representation, there is undefined the term understanding of mathematical concepts. Simply, concept is understood with the help of concept definition and concept image. Concept definitions means all the definitions that we study in mathematics, and concept image means by studying that definition or by observing the model or example of the concept, whatever is in the mind of the learner, that is the concept image. And without having the knowledge of the definitions, a student may have the concept image. For example, class 1 child can recognize different shapes, triangle, circle, etc., but he or she cannot say the definition of such types of geometrical shapes. In this way, concept definitions and concept image both are useful for the development of the idea of mathematical concepts. And regarding the understanding of such concepts, by Hibbert and Carpenter, it is mentioned that if a student construct representation for that concept in his or her mind, and if he or she is able to make that representation as the part of the bigger network of the representations, then we can say that he or she has understood the concept of that mathematical concept. And regarding the degree of the understanding, there is the criteria that if students have a greater number of association or connection between different mathematical concepts, or if there is a strength connection between different mathematical concepts, this represents the high degree of understanding. And there are factors as well that affect the understanding of mathematical concepts. These factors are existing network of representations. It means whatever exists in the mind of the learner is the existing network of representation, and ability to link a different mathematical concept is another factor. Because of these two factors, different people understand in different phase and in different level. And we can determine the understanding from the representations by strength of link, explanation of students, and reason students that can give for any mathematical concepts. And this is about the understanding of mathematical concepts. Now let me go to STEAM education. The concept of STEAM education was initiated by Georgetta Ackman in 2008. with the purpose of integrating different components S, T, E, A, and M in the different type of integrative approach, for example, multidisciplinary, interdisciplinary, and transdisciplinary approach. And after that, this concept of STEAM education has been using by different communities, different educational institutes in different ways. For example, there are different perspectives for understanding STEAM education. For example, it is considered as educational model. Some institutions are using it as a pedagogical approach, and some are using it as a curriculum perspective. Regarding educational model, it focuses on the real world complex problems, and to solve such types of problems, STEM subjects alone are not sufficient. Therefore, there is need of the integration of arts in the STEM subjects. In this way, this focus on the art dimension to include in the STEM subjects and to solve the real world problems. And another is pedagogical approach. And pedagogical approach is all about the integration of different subjects and developing 21st century skills like communication, collaboration, creative thinking, etc. in the mind of the learner, And curriculum approach is related to integrated approach. That is, integration may be multidisciplinary or interdisciplinary or transdisciplinary. And this STEAM education is based on the two perspectives, especially constructivism and transformative learning. And there are some pedagogical approaches in STEAM education, for example, design thinking, project-based learning, makerspace pedagogy, art-based methods, and inquiry-driven pedagogy. And in this way, this STEAM education is a social construct, and different communities are practicing it in different ways, and it may be different from this approach for you as well. Now let me go to the relationship between the STEAM education and representations in mathematics education. As already discussed, STEAM education focuses on the authentic activities, that is, activities from the context of the learner. And if while dealing with mathematical concepts, if teacher emphasize authentic activities, that is, activities from the context of learner, then definitely it will help a student to develop the concept image, and he or she can be able to construct different representations related to that concepts. Similarly, in mathematics, drawing and paintings can be very useful art dimensions, and they can help a student to develop the graphical representations. For example, drawing of different graphs, figures, etc. Can help a student to develop the geometrical approach, geometrical meaning, or pictorial representation of any mathematical concepts. In this way, it helps graphical representations as well as the development of the internal representations of the learners. Similarly, another dimensions of the arts are poem, song, story, dialogue, etc. In mathematics, we can develop poem by connecting different concepts belonging to any unit, and in that case, there is connection between the different concepts that can be dealt with the help of the poem. In this way, it helps to develop the connection between the different representation, as well as it helps to the development of the internal representation of the students. And STEAM education also focus on the engaging in knowledge construction. It means it focuses on the engagement of the learners in the meaning making or knowledge construction. And definitely, while students engage in the construction of knowledge, then they develop different type of representations in that case. Similarly, collaboration and communication are also valued in the STEAM education. And when students share different mathematical concepts or mathematical ideas, by sharing such types of mathematical ideas, they can develop the verbal representation of mathematical concepts. In this way, these are also helpful to develop representation. Another is Esteem education focuses on the integrating the STEAM components. It means when we deal with the concept of the mathematics, we can integrate other dimensions, science dimension, engineering dimension, art, and technology in mathematics. For example, if we are if we are facilitating the concept of limit, we can engage our students in the inquiry activity. That is, they can inquire from the internet resources as well, the different type of functions that may have a limit or that may not have limit. In this way, they can engage in inquiry activity. Similarly, we can engage students in the technological dimension. That is, use of the technology is the use of technological dimension in mathematics. Using GeoGebra in mathematics is also the technological dimension. And if they use GeoGebra, then they can get idea of different types of graph of functions. They can get idea of the meaning of the limit of functions. And when they draw different type of graphs, it means they are engaged in the engineering activities, that is designing activities. As well as in addition to this, if students are engaged in different types of drawing, painting, coloring by different type, left-hand limit, right-hand limit, if they engage in such type of activity, they can develop different type of representation. That is, they can develop multiple type of representations simultaneously, as well as the connection. They can connect between the different representations also. As mentioned above, technology helps to develop multiple representations. Engineering skills or engineering activities help for the graphical representations or connection between different representations. Project-based learning also help to connect between different representation. And when students are involved in the reflective activities, in that case also they can connect multiple representations. In this way, different perspectives that are valued in STEAM education can help to develop or to construct a different type of representations and to develop connection between such types of representations. Now let me share some examples from my context. I used to facilitate the course real analysis by focusing on definitions only. That is, I used to describe first definitions, and then I go to the proving of the theorems. But that method did not work very well. Hence, now I am practicing a new approach. That is, I am engaging students in construction of different type of representations. For example, here is the example of left-hand limit of fx is extends to a from left equals to L. In symbols, this is work done by one of the group. First of all, I divided the class into 3 groups, and this is one of the group C. And students of group C described this condition as they write in symbols in this way. Similarly, they used interval notation in place of this absolute value notation. Similarly, they wrote in by using verbal notation. For example, here to each every option positive, there is delta positive, such that when x lies in the interval this यसमा पर्यो भने fx र l को distance epsilon भन्दा कम हुन्छ. In this way, they described in verbal as well, and they translate it into the using inequality symbol, and they represent it diagrammatically. It means students represented given concept of left-hand limit from the different perspective, and by engaging this activity, they got understanding of left-hand limit, as well as they become able to connect different type of representations in a relational way. This is another example done by group A. Here is epsilon delta game. One of the group provided 2 horizontal lines at 3.2 and 4.0 here. 4.8, 3.2 and 4.8, two horizontal lines, and they challenged another group to draw two vertical lines such that the graph of the function lies between the two horizontal lines, and second group became able to find the value of delta, which is 0.7, and in this way they represented here in symbolic form, using interval notation, using graphical approach. In this way, I engaged students in different types of representations and making connection between these different type of representations as well. This is the concept of upper Darbox sum and lower Darbox sum. Here is also three types of representations. One is the by calculating areas of rectangles and summing of the areas. Second one is definition, and third one is using the graphical approach, that is sum of the lower rectangles is the lower sum and sum of the area of the upper rectangles is upper sum. In this way, I involved students in constructing representations of the different types. And as a conclusion, I found that better understanding is possible only when students can establish connection between multiple representations. And STEAM education, when we consider it as a pedagogical approach, it is helpful in constructing multiple representations and making connections between them. Thank you. These are some references. Hello.
Yeah, yes, sir. Yes. Well, thank you so much, sir, for your beautiful presentation and maybe wonderful, similarly informative too. Okay. So did you stop sharing, sir?
Sir, I already stopped sharing.
Yeah, okay. So I request our valued participants to, ask any question, as also sir, shared different ideas related to, different representation of mathematics, like internal mathematics, which is, more of mental imagery and, schema related things. So that is one of the concepts of, Piaget. And similarly, external representation of mathematics, and similarly the value of Esteem Education to teach mathematics in a meaningful way, in an integrated way. And he has also shared some of the ideas to teach mathematics and other subjects in an integrated way through Esteem education perspective and Esteem education as an approach. So I request our participants to ask a question if you have any concern related to his ideas, or you want to understand, more about whatever he uh, you know. Okay.
Asaji, may I?
Please, Deepak sir.
So I was wondering, I think you ask your student to make a sort of like project work. I think the student from real analysis class, is that what are you saying? The real analysis BSc second years, something like
It's
that?
a real analysis from limit, continuity, derivative, and antiderivative are included in fifth semester.
That
It's the project work given to fifth semester students.
and then when they were creating that graphs, do they use any technology? Is that just they use it? I think you're muted. Do they use any technology to create that graph, or they just make it by hand? I think you're muted, Harsaji. I think you need to unmute yourself.
Limit of function or
Mute
continuity of
sir.
etc. Shuniya sir. Hello.
I Balashanya Panasta.
Hello.
सर वी आर लिसनिङ टु यु हजुर हजुर बोल्नुहोस् न सर हजुर हजुर
when I facilitated the course, it means when developing concept of limited. Okay. In time of developing concept, I used algebra software as well for drawing of for activities. They don't use technology. They only in graph approach. जति शिक्षा चाहिँ मैले कुरालाई जिउ जिउ काम चाहिँ गरेँ त्यसपछिको राम्रो
खास चाहिँ मलाई एकदम सोध्नै मन लागेको कुरा चाहिँ के थियो भने जस्तो तपाईले सुरुमा तपाई सुन्दै हुनुहुन्छ मेरो कुरा नेत्रजी तपाई सुन्नु भएको छ मेरो कुरा
यस सर यस सुनिरहेको छौं
हर्षजी सुन्नु भएको छ मेरो कुरा
सुनिराखेको छु सर तर मेरो यो घुमे छ देख्न चाहिँ के
तपाईको नेट चाहिँ त्यति स्टेबल भयो जस्तो लागेन
सर सुनिराखेको
कुरा चाहिँ आधा आधा मात्रै जस्तो आइरहेको थियो खास चाहिँ त्यो प्रोजेक्टमा चाहिँ मलाई चाहिँ
मेरो यो लास्ट इयर नेटवर्क कनेक्सन
सरको डिस्कनेक्ट भयो जस्तो छ नेत्रजी पछि कुरा गरौँला क्यारे
ओके आई थिंक उहाँको अलि इन्टरनेटमा के इस्यु छ कि जस्तो लाग्यो ओके सो थ्यांक यू सो मच दीपक सर अरु सर म्यामहरुको केही छ केही कन्सर्न छ भने सो यु क्यान रेज द क्वेशन्स ओके सरको अलि इस्यु जस्तो लाग्यो मलाई सो हामी नेक्स्ट प्रेजेन्टेसन चाहिँ हजुर हजुर सर
केही सोध्दै हुनुहुन्थ्यो दीपक सरले मैले सुन्न पाएन नेट गयो केही
ओके
दीपक सर यु वान्ट टु आस्क अगेन म तपाईसँग पछि नै सोधौँला यहाँ अहिले किन टाइम धेरै लिनु हैन इट्स ओके
Okay, so thank you so much, Harsh sir, for your wonderful presentation. So our next presentation will be on, model drawing methods in teaching mathematics, so which is one of the, great and practical methods to teach mathematics in a meaningful way. So the presentation will be presented by YP Joshi, A.K. Prakash Joshi sir. So A.K. sir, are you ready with the presentation?
Yes, sir, I'm ready.
He's also a scholar of MA in Mathematics Education. So YP sir, please share your screen.
Okay, sir. Thank you so much, sir. Okay, so is it visible, sir?
Yes, sir. Yes, it's visible.
Well, good evening, everyone. Before I introduce myself and my topic, let me ask you a question. Probably, I think we all are the teachers. If not, we can share the experience of learning also. So during our school time, the question is the bridge to connect my topic to. So I hope that all of you will try to share your experience and ideas. So the question is on the screen. So you are seeing clearly. The sum of the two numbers is 20 and the difference is 16. Find the numbers. Very simple questions. But the question is not to solve this because if you belong to mathematics and if you all are the mathematics teacher, it's not the great deal. So just the question is, how have you taught this question as a teacher, or how have you learned as a learner, or how can you teach in different possible ways? So please, can you share your ideas? Can anybody share your ideas regarding this question? So as a teacher, how have you taught this question in your classroom? Anyone? Just I want to be confirmed about the practices and experience that you have done. Netha sir, so is there any response in the comment?
Yeah, definitely. There are some, comments, and Deepak sir said that in algebra, graph method, matrix method, guess and check methods.
Okay. Yeah. And others?
No,
Okay,
there are no
well,
other.
thank you so much for the creative sharing, sir. So what happened if we do this way? For example, if we represent the number, the first number by this block, yaks, and the question is saying that the difference is 16, that's why the second number must be greater than the first number by 16 or less than 16. So I suppose that the second number is greater than by 16, then there are altogether 2x and 16, then it becomes 2x plus 16 is equal to 20, isn't it? Because the question is saying the sum of two numbers is 20. So from here we can find that the value of x is 2. So after getting the value of x, we can find the value of x plus 16 also. So what is the differences that we found from this method and the method that we are using in the classroom? I think most of the teachers may use this method also. It's not new for someone. So even then, this I want to ask. So what is the special that we can get from this kind of problem solving? So is there any answer from anyone? So we can unmute and respond directly also.
So this is a nice way to represent the problem itself. I mean, it just gives you the multiple perspectives.
Yes, thank you so much, sir. Yeah, of course, because it gives the visualization to the verbal problem also, isn't it? So it will be a little bit easier for the students too. So today I'm presenting on the same topic. So that means I'm presenting on the integrating model drawing method in mathematics teaching. So good evening, everyone, once again, and welcome. So it's me, YP Joshi. So I'm a scholar of Kathmandu University of 2019 batch. As a profession, I'm a teacher and head of the Department of Mathematics in Imperial World School, Budanilkanta. So in my 19 years experience of teaching, I have learned and researched so many things for me personally, but of course some of them are worth sharing also. That's why I'm going to share my ideas. It's not my ideas actually. So I have long studied, I have researched from somewhere. So in integrating model drawing method. So let me share it. So I'm not going deeply in the literature because I want to make my presentation implicable in the classroom. So that's why. So before going to my topic, so here is the quotation. So you can read the quotation. The quotation. So here is a beautiful quotation for the teachers that is said by Scott Hayden. So it defines the three loves of the teachers. Actually, one of the teachers must love learning. Next, they must love the learners, and they must love to connect them or bring them together. So now here goes my presentation synopsis. So on the first slide, I'm going to give a little bit introduction of model drawing, and then addition and subtraction models is for the base. So I'm focusing on the last some slides, but I have included some of the basic concept for the model drawing. So here addition and subtraction model is on the second slide, and then multiplication model, division model, comparison model, fraction model, average model, ratio model, the axis value concept model, and arithmetic progression and geometric progression model, simultaneous linear equations, and Yumpy discount and fat. So how can we do the questions related to these contents using model drawing? So let me introduce my topic. Actually, model drawing method is especially originated in Singapore. So we can say Singaporean method also, in order to make some positive change in primary mathematics curriculum. So especially rectangular bar diagrams are used as models which represent known and unknown mathematical quantities. And it is too much effective approach to solve verbal problems, as it focuses on visualization of the problems, which makes quite easier to solve the problem. So I don't want to waste the time in theoretical part. So let's directly connect this presentation to the classroom implication. So here, let's go to the addition and subtraction model. So it's the very basic part for today, addition and subtraction model. So here is one question. I had 5 marbles. My brother gave me 2 marbles. How many marbles do I have now? So it's the simple question actually. So how can we do by using model drawing method? So we can draw a block that represents 5. As 2 marbles are given by the brother, so another block should be added that represents 2, and which must be smaller than the previous block. Uh, and students will visualize that they need to add 5 and 2 to get the solution. In other words, they need the single number that combine both these two numbers. So it can be written as 5 plus 2, or we can say, so 5 plus 2 is equal to x. So we can connect with algebra too. Similarly, so here is another question. Ram lost chocolates, 5 chocolates out of 7 chocolates. How many chocolates are left? So let us draw a block that represents 7. So another block that represents -5. So in this way, now the remaining will be the answer, which helps visualizing subtraction. So we can write 7 minus 5 is equal to what? Or x is equal to 7 minus 5. So it helps students visualizing the subtraction in the word problem. So here is another questions. My mother bought 12 copies. She gave 4 copies to my younger brother and 3 copies to my younger sister, and the remaining copies to me. How many copies did I receive? So in order to solve this question, so we can first of all draw a block, so which represents 12. So because my mother bought 12 copies, then she gave 4 copies to my younger brother, 3 copies to the younger sister, and remaining copies. So I need the remaining block that covers the remaining part. So that is my answer. So it again helps to visualize the remaining part, and the remaining part will be like this. So 12 minus 4 minus 3 is equal to what? Or x is equal to 12 minus 4 minus 3. And now, so I have another here, multiplication model. Now let's see the question in multiplication model. So Ram has 7 marbles. Sam has thrice as many marbles as Ram. How many pens does Sam have? It's a very simple question. So for this question, we can represent the number of marbles with Ram by a block. So Ram has 7 marbles. That's why this block represents the number 7. Since Sam has 3 as many marbles, so we represent by 3 blocks of equal size. So like this. So that represents 3 times of 7, which is, of course, 21. So it is also the visualization of that verbal problem. So now division model. So it's the turn to the division model, and here is the question: distribute 10 copies equally to 5 children. So find the share of each. So we represent first of all 10 by a block, and then we divide it into 5 equal parts, because we have to distribute these 10 copies to 5 children equally. So that's why I divide it into 5 equal parts, and it gives a clear concept. So either we can write 10 divided 5, or 10 divided 5 is equal to x, or we can write 5x is equal to 10 also. So here is 5, here are 5x, so 5x makes 10. So in this way, it is also the visualization of the above verbal problem. So now, so I have here another comparison model. So comparison model means less than, greater than, or more than, less than, so like that. So here I have 2 more than 14. So we can have a block that represents 14. Another number should be 2 more than 14. So it can be represented this way. So similarly, we can represent 2 less than 14 also this way. First of all, we draw a block for 14. Then we subtract 2 from 14. The remaining part is 14 minus 2. So that means that x represents 14 minus 2. That is 12. So now the fraction model. So here is the question. 1/3 of a number is 6. Find the number. Now, so let's draw the required number. So this is the block, so that represents a required number. And the question is saying 1/3 of a number is 6. That means we have to divide this number into three equal parts at first. So in this way, and one part represents 6. So the question is saying 1/3 of a number is 6. That's why that one part is 6. In the same way, another remaining two parts are also 6, 6, 6, 6. So in this way, whole number will be 3 into 6, 18. So how simply the students get the answer visualizing the word problem. So 1/3 of a number is 6. Otherwise, what we used to do, so we used to write late the required number be x, that, and then according to the question, so 1/3 into x is equal to 6, x equal to 6 into 3, 18. So by drawing the models, it makes them a little bit easier to develop the concept on the problem also. So next here, 3/4 of a number is 21. So find the number in the same way. So first of all, so I have to draw a block for the required number. And then, so I divide into 4 equal parts. And among 4 equal parts, 3/4 means 3 parts represents 21. So look, so this 3 part represents 21. That means 3x means 21, is it? 3x means 21. So, but I need the value of this yellow block. Yellow block means 4x. So so I'm given the value of 3x. So 3x means 21. Now I need to find 4x. How to find 4x? So first of all, I need to find the value of x from here. X equal to 7, and required number is equal to 4x, and 4x is equal to 28. So the required number is 28. So now next fraction model. So the continued. So here is another question. Ram had 25 marbles. 4/5 of his marble is equal to 2/3 of Sam's marbles. Find the number of marbles with Sam. So I have made the models like this. So Ram has altogether 25 marbles, and the 4/5 of the marble is equal to the 2/3 of the Sam marble. So I have divided the number of marbles into 5 equal parts because I need 4/5. So that's why. And I divided the parts, so the number of marbles with Sam in 3 equal parts because I need 2/3. Yes. So what the question is saying? 4/5 of his marble is equal to 2/3 of Sam's marbles. 4/5 means, so 1, 2, 3, 4. This 4x. So 4x must be equal to 2/3 of the Sam's marble. 2/3 means this 2x plus 2x means 4x. So these 2 greens will be equal to these 4 blues. Yeah. So we can write like this. So 5x is equal to 25 according to the question. So altogether, because the Ram had altogether 25 marbles. Yes. So that means so 5x is equal to 25. So we will get the value of x. X means 5. So after getting the value of x, so we need the number of marbles with Sam. So if it is 4x, so these 4 parts represent 4x, then these 2 parts obviously represent 4 parts, because by the question 4/5 of his marble is equal to the 2/3 of the Sam's marble. But if this is 2x, this is 2x, this is also 2x, altogether the number of marbles with Sam is 6x. Then we need the value of 6x. So number of marbles with Sam means 6x, which is 30. And so here is the average model, so especially to teach mean. So find the average of 6, 8, and 13. So we can do like this: 6, 8, and 13. So the altogether the sum is 6 plus 8 plus 13 means 27. Now we have to rearrange these blocks in such a way that so each of the term must be equal to each other. होइन भन्छ यो प्रत्येक नम्बर चाहिँ एकअर्कासँग बराबर हुने गरी हामीले बनाउँछौँ. जस्तो यो 6 छ, यो 8 छ, 13 छ भने हामीले एउटा यस्तो नम्बर चाहिँ बनाउँछौँ 6 लाई पनि, 8 लाई पनि, 13 लाई पनि, जुन चाहिँ यो तीनटा फरक छ, कुनै बढी छ कुनै कम छ, इक्वल नम्बरमा हामीले डिभाइड गर्ने नम्बर खोज्छौँ लाइक दिस. सो विल सपोज दैट दोज नम्बर्स इज x x x. हुन त हामीसँग यो टोटल नम्बर नै चाहिने हो. हामीलाई 27 एउटा नम्बरलाई नै हामीले यसरी बराबर पार्टमा डिभाइड गर्ने हो हैन. त्यो के हो त भन्दाखेरि हामीले x x x एज्युम गर्यो. त्यो गर्ने बित्तिकै इट मिन्स 3x इज इक्वल टु 27 एन्ड x मिन्स 9. सो अनदर वे, अर्को वेबाट गर्ने हो भने हामीले के पनि गर्न सक्छौँ. जस्तै यो फिगरलाई, यो पहेँलोलाई मैले यतातिर ल्याएर हामीले बराबर, त्यो मैले अघि भनेको कुरालाई एक्सप्लेन गर्दाखेरि मैले सबैलाई बराबर बनाउन खोजेको मात्र हो. यो 6 8 र 13 बराबर छैन, हामीले त्यसैमा भएको सङ्ख्यालाई समलाई चाहिँ बराबर तीनवटा पार्ट्समा डिभाइड गर्दाखेरि now it becomes 999 and the 9 is the average. So now let's go to the next ratio model. So here is the question. The ratio of the number of boys to girls is 2:7. If there are 18 boys, how many girls are there? So how can we do this? So look at here. So I have separated 2 blocks for boys and 7 for girls because the ratio of the number of boys is 2:7. So altogether there are 9 parts. Among 9 parts, 2 parts for the boys and 7 parts for the girls. So if there are 18 boys, 18 boys means, so look at here. So x plus x, so there are 2x boys, yeah. So that's why, so 2x is equal to 18. So in this way we can write 2x is equal to 18 directly. If 2x is equal to 18, x is equal to 9. So one important thing that I want to share is, if students try to make the model at the beginning, later they should not have to make the model in their copy. They just imagine themselves in their mind, and they can write directly also. They can solve the problems directly. So model drawing means it is not necessary to draw every time in their copy. Just in the beginning they develop some concepts. So what is 2:7? So what does it represent in the visual form? And later they can visualize in their mind and solve the problem. So here I need the number of girls. So number of girls means 1x, 2x, 3x, 4x, 5x, 6x, and 7x. So it means 7x means 70 to 9, of course, 63. So now another ratio model, same. So I'm continuing, but I have slightly changed the question. The ratio of the number of boys to girls is 2:7. If there are 45 more girls, how many boys are there? 45 more girls. So just we have to focus in this word. So let's see the models. So again, the diagram is same, 2:7. The ratio of the boys and girls is 2:7. That's why, so these 2 blocks for the boys and 7 blocks for the girls. So that means 2x and 7x. And if there are 45 more girls, 45 more girls means boys भन्दा बढी भएको यक्सहरू हामीले हेरौँ त. जस्तै बोइजसँग 2टा यक्स छ, गर्ल्सको लागि यो 2टा यक्स बाहेक बाँकी रहेको यक्स छ नि, यो पछाडिको 1 2 3 4 5, यो 5x भनेको मोर हो हैन. 5x भनेको 45 भनेको यसको मतलब, किनकि यो 2टा यक्स र 2टा यक्स त बोइज र गर्ल्सको बराबर भयो. गर्ल्सको संख्या बढी बनाएको भनेको पछाडिको यक्स वाला ब्लकले हो. So that means 5x is equal to 45. So if 5x is equal to 45, and of course x is equal to 9. And we need the number of boys. So number of boys means 2x. So clearly there is given number of boys is equal to 2x, and 2x is equal to 18. And it means the number of boys is 18. Now next question, again slightly changed. The ratio of the number of boys to girls is 2:7. If there are 81 altogether, how many boys and girls are there? So same block, same diagram is drawn here. So 2 blocks for the boys and 7 blocks for the girls. So altogether there are 81 people. So that means 1x, 2x, 3x, 4x, 5x, 6x, 7x, 8x, 9x is equal to 81, isn't it? Altogether there are 81. So that's why, so 9x is equal to 81, and it gives x is equal to 9. So how many boys and girls are there? The question is how to find the number of boys and girls. So number of boys is 2x. So these blue blocks represent the number of boys. So that means 2x, and 2x is equal to 18. And number of girls is equal to 7x. So that is 63. Now the access value concept model. So here is the question. A farmer has some animals, either hens or goats. So there are altogether 36 hens and 100 legs. How many hens are there? So this kind of questions are asked in IOG examination also. So I think so most of we are familiar with this. So how can we do these questions? By using model drawing method. So let's see. So a farmer has some animals. So we represent one animal with 2 legs by 1 block. So like this. So one animal. So this block, this blue blocks represent one animal with 2 legs. But so what the question is saying, there are altogether 36 hairs. So there are altogether 36 hairs means So one head per animal. That's why we can say that there are altogether 36 animal. That's why 36 animal with 2 legs. So we'll assume that all the animals have 2 legs at first. So then it becomes, since there are 36 heads, so there are 36 animals, and 36 animal with 2 legs means, so like this, so 2 legs. So we cannot make 36 blocks right now, so it will take time. That's why we will uh, represent in this way if we need too many blocks. So 2 legs but 36 times, so it means 72 legs. Yeah, but so if they are all are hens, then they have a total of 72 legs. But so read the question again. So what is the question? So there are 100 legs. Yeah, so if there are only the 2 legs animal, then there must be 72 legs. But question is saying that no, there are 100 legs. So that means where are that 28 legs gone? So that 28 legs are extra. So that's why so this 28 legs are extra. Now that's why what we do, so extra legs will belong to goats. We are sure that so there are animals having 4 legs also. So extra legs belongs to goats. So each goat should get 2 extra legs. Yeah, because 2 legs are already calculated in the previous problem. So 2 extra legs is, so that means 28 extra legs divided by 2 extra legs means 14 goats. So it means, so there are 14 goats, and altogether there are 36 animals. That's why 36 animal minus 14 goats means 22 heads. Now arithmetic progression. So in an arithmetic progression, the sixth term and the 10th term are 8 and 20 respectively. Find the fourth term. So usually what we do in grade 10, students make the equation. So they write 10th term is equal to 8. That means a plus 90 is equal to 8, equation 1. Then a plus, a plus 5d is equal to 8, equation 1. And then 10th term is 20. That's why a plus 9d is equal to 20, equation 2. Solving equation 1 and 2. So in this way, they find the value of a and d. So after making the blocks, they can generalize the idea. So here, so we are given 6th term and 10th term. That's why I have made 6th term, 7th term, 8th term, 9th term, and 10th term. I already told you, in the beginning, so we can make the blocks, but later they can generalize themselves, because we cannot make the blocks if the question is like this. So you are given a 6th term and you are given 600th term. So we cannot make so many blocks. So it helps us generalizing the idea also from the simple question. So 6th term means here 8. So it is an arithmetic progression. That's why what we can say, 7th term. So there is a common difference between each two consecutive term. So suppose that consecutive term is d, then 7th term will be 8 plus d, 8th term will be 8 plus 2d, 9th term will be 8 plus 3d, and 10th term will be 8 plus 4d. 8 plus 4d means 20, because question has given 10th term means 20. 8 plus 4d is equal to 20. So 8 plus 4d is equal to 20 means d is equal to 4. So after getting d is equal to 4, we can find fourth term. Fourth term means 6th term minus 2 into d, isn't it? So that means 6th term is already given here 8. 8 minus 4 is equal to 4. So look how easily, how simply, how fast we found the solution, isn't it? So we should not have to make these blocks again and again later. In the beginning, we can ask students to draw the blocks. So later they can generalize their idea themselves. So look at here, they get here 8 plus 4d. 4 means 10 minus 6. 10th term and 6th term are given, 10 minus 6 is 4. So they can generalize their idea after doing so many questions, and they can do other questions also in the same way. So now geometric progression in the same way. So in a GP, the 6th term and the 10th term are 10 and 160 respectively. Find the fourth term. So here 6th term, 7th term, 8th term, 9th term, and 10th term. 6th term means already given 10. And in geometric sequence, we know that so there exists a geometric common ratio between each two consecutive term. So that's why we have to multiply by a scalar. So that suppose that is r. Yes. So 10 into r, it becomes 7th term. Then again, we have to multiply by r, and we get 8th term, then 9th term, then 10th term. And 10 r power 4 means 160. And if 10 r power 4 is equal to 160, r is equal to plus minus 2. So after getting r is equal to plus minus 2, we need to find the fourth term. Fourth term means 6th term upon r square. So that means 10 by 4 is equal to 5 by 2. Now let's solve the problems of simultaneous linear equations. So so I have given the questions at the beginning also. So let's see this question. The sum of two numbers is 21. If a number is double of another number, find the numbers. So we'll assume that the first number is x. Okay. Then what the question says, another number is double of the previous number. So we can write this way. Second number means 2 blocks. Yeah. First number represents 1 block, and second number represents 2 blocks of equal sizes. So altogether we have 3x, isn't it? So that means 3x is equal to 21. The sum of a two number is 21, means 3x is equal to 21, and x is equal to 21 by 3, and x is equal to 7. And we can find both the numbers. The first number is x, that is 7, and second number is 2x, that is 14. So generally what we do, we write let the required number be x and another number be 2x, but students don't know what does that x mean. So it helps in that case also. Okay. So here is another question. From the age of a person, if 2/5 of his age is subtracted, the result becomes 24 years. Find the age of the person. So here we are given. So from the age of a person, if 2/5 of his age is subtracted, that's why I have divided the age of a person in 5 equal parts. Yes, 5 equal parts. So this is this all blocks represents the number of the age of a person, the number that represents the age of a person, and 2/5 of his age is subtracted. 2/5 means this blue colored. Yes. So if I subtract this 2/5, then green only left, green color left. So that means 3x will be left. So 3x becomes 24, isn't it? According to the question. So 3x is equal to 24 and x is equal to 8. And so the age of the person is equal to 5x years, which means 40 years. Now, another question. So 1 by 5 of the age of a father is the age of his son. If the sum of their ages is 42 years, determine the age of the father. So father is divided into 5 equal parts because I need 1/5. So this 1/5 part will be the age of the son also. So this green is equal to the one blue block. Yes. So now the sum of their ages is 42 years. So sum of their ages is 42 years means, so we have to add this all. How many x are there altogether? 1, 2, 3, 4, 5, 6x. That means 6x is equal to 42. So if 6x is equal to 42, x is equal to 7. And thus the age of the father is equal to 5x years, and so it means 35 years. Now simultaneous linear equations, another question. The sum of the ages of the father and son is 44 years. After 8 years, the age of the father will be twice as old as the age of the son. Find their present ages. So what we can do here, so present age of the father is represented by blue block, and here by green block. So of different size. Yeah, so the age of the son is sure small, so smaller than the age of the father. That's why I represent by the small block. So what the question says, the sum of the ages of the father and son is 44 years. That means blue block plus green block must be 44 years. After 8 years, so I'm talking about the present age right now, but after 8 years, the age of the father will be twice as old as the age of the son. The age of the father will be twice. So let us find the age after the age after 8 years. 8 वर्षपछिको उमेरको उमेर के हुन्छ एकचोटि ध्यान दिएर हेरौँ त। जस्तै बुवाको उमेरमा 8 वर्ष जोडिन्छ 8 वर्षपछि, हैन? यो बुवाको उमेर हो, यसमा 8 वर्ष जोडियो। अनि छोराको उमेरमा पनि त 8 वर्ष जोडिन्छ नि, हैन र? त्यसको छोराको उमेरमा पनि 8 वर्ष जोडियो, गर्दाखेरि दुईटा 8 वर्ष जोडियो के 44 इयर्स। अगाडि अहिलेसम्म तिनीहरूको उमेर जोड्दाखेरि 44 इयर्स थियो, दुईटा 8 वर्ष जोडिनु भने 16 इयर्स जोडियो के। यसको मतलब अल टुगेदर 60 इयर्स रहेछ। 8 वर्षपछिको उमेर जोड्यो भने चाहिँ 60 इयर्स हुन्छ भन्ने कुरा हामीले यहाँबाट बुझ्न सक्छौँ। अब अर्को कुरा के पनि बुझ्न सक्छौँ भने छोरोको उमेर चाहिँ अहिले x हो भने x + 8 हुन्छ, तर बुवाको उमेर चाहिँ के होला त? पछाडि क्वेसन पढौँ त। सेकेन्ड स्टेटमेन्ट, आफ्टर 8 इयर्स द एज अफ द फादर विल बी ट्वाइस एज ओल्ड एज द एज अफ द सन। भनेपछि बुवाको उमेर चाहिँ छोराको उमेरको डबल छ नि त, x + 8 को डबल हुने भयो। त्यसो यो निलो ब्लक र यो कालो ब्लक, लास्टको कालो ब्लक र सुरुको निलो ब्लक चाहिँ बुवाको एज हो। त्यो भनेको चाहिँ 2 times एज अफ द सन हुन्छ त्यति बेलाको 8 वर्षपछिको। द्याट मिन्स 2 times of x + 8, इट मिन्स 2x + 16। यस, अब हामीले के गर्न सक्छौँ, बुवाको उमेर र छोराको उमेरको त्यति बेलाको सम जोड्यो भने त 60 हुन्छ नि। क्वेसनले भने हो नि, मैले भने त होइन। सो x + 8 + 2x + 16 यो छोराको उमेर 8 वर्षपछिको, अनि यो चाहिँ बुवाको उमेर। सो इट बिकम्स 3x = 36 and x = 2. So in this way, so we get the present age of son and the present age of father. Last slide for the mark price, a discount and VAT. So if a watch was sold for rupees 1,656 after allowing 10% discount on the mark price and adding 15% VAT, find the discount amount. So here, how can we do? So mark price means एकछिनको लागि मार्क प्राइसलाई 100% मा चाहिँ हामीले चाहिँ मान्ने हो भने 10% त डिस्काउन्ट दिएको हो नि त हैन। त्यसको रेशियो सेपरेट गर्ने हो भने 90:10 रेशियो होला पक्कै पनि। 90 चाहिँ 10% चाहिँ डिस्काउन्ट दियो। 10% डिस्काउन्ट दिइसकेपछि बेचेको कतिमा त उसले 90% मा बेचेको हैन। पछि 90y मा उसले बेचेको हो, 10y मा उसले चाहिँ डिस्काउन्ट दिएको हैन। भनेपछि यो 90y भनेको सेलिङ प्राइस हो। भ्याट लाग्ने भनेको यो निलो ब्लक छ नि 90y मा चाहिँ भ्याट लाग्छ। 10y त डिस्काउन्ट दिएको हो उसले हैन। अनि अब हामीले यो भ्याट लगाउँदाखेरि ठ्याक्क त्यो निलो ब्लकलाई चाहिँ 100x भनेर एज्युम गर्छौँ। त्यो चाहिँ सेलिङ प्राइस हो। अनि त्यसमा चाहिँ 15% भ्याट चाहिँ एड हुन्छ हैन। सो 115x हुन्छ। भनेपछि अब हामीले के गर्न सक्छौँ, यहाँ हामीलाई दिएको के छ, भ्याट सहितको मूल्य। सो विथ भ्याट, so the watch is sold at rupees 1656. That means with that means 100x plus 15x. That means 115x. 115x भनेको 1656 हुँदो रहेछ। सो यहाँबाट हामीले x को भ्यालु निकाल्न सक्छौँ। अनि तर हामीले चाहिने त डिस्काउन्ट अमाउन्ट हो नि, हामीलाई 10y को भ्यालु चाहियो नि। तर मैले अघि के भनेको, यो 100x भन्नु र 90y भन्नु त सेम हो नि त, किनकि हामीले यो अघि जुन सेलिङ प्राइस थियो नि, यो चाहिँ मार्क प्राइसबाट यो हरियो घटायो भने जुन निलो भाग बाँकी जुन आउँछ त्यो चाहिँ एसपी आफ्टर डिस्काउन्ट हो। डिस्काउन्ट घटाइसकेपछिको सेलिङ प्राइस हो। डिस्काउन्ट घटाइसकेको सेलिङ प्राइस तल गयो, त्यसमा चाहिँ 15% भ्याट जोडेको हो नि त हैन। त्यो भएर माथिको त्यो 90y भन्नु र 100x भन्नु एउटै हो। x को भ्यालु आइसकेपछि 100x को भ्यालु आउँछ। त्यो 100x भनेको 90y हो, अनि जुन भनेको 1440 हो। यहाँबाट हामीले 90y आयो भने 10y निकाल्न त हामीलाई अब कसले रोक्न सक्छ। सो y = rupees 16 and the discount amount is 10y = rupees 160. So in this way I have brought some samples. So actually what I mean to say is yeah, I know that in the starting phase students may find little bit, some of the students may find little bit difficult also. जस्तै मैले पनि क्लासमा यसलाई युज गर्दाखेरि कतिपय स्टुडेन्ट्स जसलाई चाहिँ भर्बल प्रब्लम गाह्रो लाग्थ्यो उनीहरूले सजिलो पनि फिल गरे, तर कसैलाई चाहिँ अझ बढी कन्फ्युजिङ पनि लागेको हो। तर उनीहरूलाई अलिकति बढी, किनकि उनीहरूलाई सानो सानो पार्ट्सहरू पनि थाहा छैन नि त तलदेखिको, त्यसले गर्दाखेरि उनीहरूलाई चाहिँ माथि डाइरेक्ट सिकाउँदाखेरि अलिकति समस्या पनि आएको छ। त्यही भएर हामीले सानैबाट एडिसन मोडल, सबट्र्याक्सन मोडलका कुराहरू पनि जोडेर उनीहरूलाई चाहिँ ब्लक बनाएर सिकाउन थाल्यो भने उनीहरूको त्यो प्रब्लमहरूलाई दिमागमा भिजुअलाइज गर्न सक्ने अथवा सोच्न सक्ने, त्यो चित्र बनाउन सक्ने, यसले यस्तो भन्न खोजेको भनेर दिमागबाटै पनि अलिअलि सामान्य क्याल्कुलेसन गर्न सक्ने, चित्रलाई चाहिँ क्लियरसँग देख्न सक्ने भनौँ न, त्यो कोही प्रब्लमलाई क्लियरसँग देख्न सक्ने एउटा क्षमता चाहिँ बढ्छ जस्तो लाग्छ। फेरि वाट आई मिन टु से, यसलाई चाहिँ हामीले यो बेटर अप्सन, बेटर वे भनेर भन्न नभनौँ, तर अल्टरनेटिभ को रूपमा लिन सक्छौँ। जस्तै डिफ्रेन्ट एप्रोचबाट हामीले क्लासमा पढाउँदै जाँदाखेरि कुनै न कुनै स्टुडेन्ट्सलाई यो एप्रोचले पनि काम गर्छ र सम्भवतः म्याक्सिमम स्टुडेन्ट्सलाई काम गर्न सक्छ बिस्तारै हैन। त्यो भएर चाहिँ so this is my presentation. So if there is any questions regarding to this, again I want to say, so I'm not an expert on this, so I'm just a learner. मैले पनि खोजिराखेको छु र मैले पनि युज गरिराखेको कुराहरू हुनाले just I have said in today's webinar. So if there is any question regarding to this, so you can please raise your question.
Okay, thank you so much, Ege sir, YP sir, for this wonderful, informative, and very practical, presentation and session. So I hope the models, different model drawing methods you shared are very, very useful for mathematics teachers to teach mathematics in a different way, in an alternative way, and I think in a practical way by connecting, mathematical problems to the blocks and, models. So as you said, I request our participants or ma'am to share or ask questions if you have any, or you want to you need any more clarification, whatever YP presented. You are all welcome.
So let me ask one question, I think.
Deepak sir,
Yes,
Yeah. So
yeah, sure, sure, sure.
what grade particularly you are using this? Do you what grade do you teach actually?
so I'm a second level teacher, 8, 9, and 10. I'm using for the students of grade 8, 9, 10, but we can use this model for the students of grade 4, grade 5, grade 6 also. So after they learn addition, subtraction, so when they have to deal with the verbal problem, so to understand the verbal problem in visual form, so we can use it.
So now, what exactly is the resistance when you use it? Like you mentioned that sometimes it's difficult to convince a student to get used to with this method. Like what is their reaction? I mean, how do they
Yeah,
react when you?
yes, sir. But most of the students feel a little bit easier. But some of the students, those who have really problem with the fraction, because so here the concept of fraction is used in maximum case, because we have to divide the blocks into different fractions. That's why if we develop the concept of fraction to the students, then it will be a little bit easier. We have to start from grade 4 and grade 4, grade 5 to make it easier in the senior classes too.
All right, I know that Netra Ji also did the kind of research. I think that's with the middle school or maybe high school. I don't know. And they found that our students are very good at procedural knowledge, but if you try to introduce something conceptual like you started, they do not have patience, or maybe they're not happy to learn in a creative way, because the examination system doesn't really demand
Yes.
a student to write their answer in a creative ways. So that's why I was thinking, like, when you do this kind of stuff, which is very good. I mean, we should be doing more of this in our classroom. Um, so that's why I thought, like, the reaction of a student, how they react, because given the evidence that not many students are happy with the method you introduced just recently. Yeah.
Uh, yes, sir. Thank you so much, sir. And so I have already told, and again I want to say that. So actually, we have to use multiple ways in the classroom. So the single method might be applicable for certain students. So multiple, because students have the different abilities, different way of learning. So that's why we have to address the different ways of learning of different students. So certainly, so this method is also one of the most useful. So because I have already used in the classroom, and maximum students, those who feel really difficult with the verbal problems, those who are unable to do the problems by using formula, so even they feel a little bit easier with this. And some few students, those who have really basic problems, so they feel a little bit difficult, and we can use another method to them, or we can develop some basic concept and then use the same method to them also, to bring some passion in mathematics.
All right. Thank you.
Okay, sir. Thank you, sir. Welcome, sir.
Okay, thank you so much, Deepak sir, for the question and concerns and ideas. Well, I don't think our participants, sir, ma'am, have questions regarding your presentation. Once again, thank you so much, YP sir, for bringing this, wonderful ideas
Thank you.
and applicable ideas. And similarly, I would like to thank Harsha sir for your informative and valuable presentation. So with this, we'd like to end today's webinar session. So this is our seventh session, and I'd like to inform you that we run this type of session weekly on a weekly basis. Thank you so much for joining us, everyone. So we'll meet in the next session. Thank you so much. Have a
Thank you,
good day
sir.
and good night.
Thank you, sir.
Thank you, sir. Thank you, all of you.
Sir, Netra sir.